All right, thank you everybody for coming to Sex and Gender Research Mechanics, Best Practices from Grant Writing and Study Design to Manuscript Preparation. And here are our panelists, myself, Tracy Madsen, Dr. Basmah Safdar, Dr. Jeannette Wolfe, and Dr. James Paxton. All right, so session objectives. We're going to cover a lot in 50 minutes. We're going to first, I should say, we're going to describe these things to you, and the objectives for the audience will be that the participant will be able to describe NIH grant requirements for addressing potential sex differences, describe the components and purpose of the SAGER guidelines. For those of you that are not familiar, these are going to be a great tool for you to use for your own work. Explain the role of the IRB in promoting inclusive research, demonstrate 2 statistical methods for evaluating sex differences, and finally, the final objective to critically appraise new evidence by applying principles of sex-specific research. And with that, I'll bring up Dr. Wolfe.
Good morning, everybody. Thank you so much for spending your Friday morning with us. We know that you have so many other commitments right now, and we appreciate you coming by. So why are we all here? Why is this worth your time? Well, I think everybody at SAM can agree that we have 2 common shared goals. We want to practice up-to-date science, and we want to optimize patient outcomes. Well, everybody here wants to remind you, in 2023, we sincerely and authentically think you cannot do this unless you consider the variables of sex and gender. So let's go through some straightforward definitions. Biological sex and gender are still often interused in medical and research papers, and we really need to change that practice so we collect more effective and more data that is more easily translatable from study to study and field to field. So when we talk about biological sex, we are talking about the physiologically innate differences between males and females, including their chromosome, their hormones, their anatomy. From the 2016 definition of the NIH policy on sex as a biological variable, sex is a biological variable defined by characteristics encoded in DNA, such as reproductive organs and other physiological and functional characteristics. But you say, wait, not everybody falls into a binary biological sex, and that is true. There is a large umbrella of intersex individuals, and we need to figure out how we include these in research. We could do an entire talk right now on how you appropriately enter demographic data to capture sex, gender, intersex differences, but then we would have no time for the rest of this talk. So I'm going to refer people to a 2022 National Academies of Science paper called Measuring Sex, Gender Identity, and Sexual Orientation, so you do not need to reinvent the wheel. A bunch of really bright people across multiple academies in the NIH have already done the hard work for you. Read the paper and find out how you should ask these questions in your own research. So what about gender? We think of gender as more of a social cultural attribute that includes our gender expression, our gender roles, and how we perceive ourselves in the world. When we look at gender, again, this is not a binary. At the extremes, the bookmarks are woman and man, but in between there's a lot of new different variations, trans, non-binary, other. Again, you do not need to reinvent these definitions. Find out who other people have already done the hard work for you to ask these questions accurately, because it's not as easy as just saying to a patient, are you transgender? Because you could have somebody who was biologically identified as a female at birth and who is now identifying as a man, and they may not include themselves in that transgender category because they don't consider themselves transgender, they consider themselves a man. So when we look at this data, In the ideal world, we could draw a nice straight line between sex differences and social cultural ones, and sometimes we can. We know that pharmacokinetics are very biologically sex-based. So we know that if I and my husband drink a lot of beer in an aftermath party, that his alcohol dehydrogenase works differently than mine because it is enhanced by testosterone, and he is going to eat away his alcohol much faster and less is going to be absorbed. We also know that there are gender differences. We still lived in a very gendered profession world. We have more people who work in long-term care facilities and healthcare who are women. We have more people who work in federal prisons and manufacturers who are men. This affects our disease exposure. However, in many times, our biological sex sort of naturally blends into our gender. Perfect example of this is, what is a gender reveal party? Do we really know our child's gender at 6 months old? Another perfect example of this is we know from scientific data that if, again, my husband and I were to collapse in a mall from a cardiac arrest, there's about a 6% difference that he will be more likely to get CPR than I am. Is that a physiological difference? There's something that is intimidating about doing CPR in somebody who has more breast tissue, or is it a social cultural difference that there's something fundamentally different about touching a woman's breast versus a men's breast? However, if you really get into this data, it's really not a vertical line or a horizontal line, it's more of a circle. And that's because we know through epigenetics that men and women can be exposed to the same exact pathogen, infection, toxin, and how they physiologically respond in their genome can be different. And my academic crush, Dr. David Page, who studies the Y chromosome, has this wonderful quote. He says, unless we arrive at an appreciation of how males and females read their genomes differently, we will continue to be surprised every time we encounter sex difference in disease. So before I hand it off to one of my colleagues, I'm going to introduce the SAGER guidelines for people who don't know this. This was introduced in the mid-teens, 2015, 2016, by an editorial group in Europe where they got together a lot of researchers, authors, editorial journalists, journal companies, the people who are reviewing your papers, and they came up with the SAGER guidelines because they wanted to have a template that could be consistently used across all fields to tell each other plainly what we're doing and what we're not doing in our research. So SAGER stands for Sex and Gender Equity in Research. As an aside, I do a podcast called Sex and Why. I had a chance to interview the primary author of this, Shirin Hadari. And one of the things that is so amazing about Shirin is she's looking at changing systems to more rapidly implement biological sex and gender as a variable versus us going to individual researchers saying, hey, have you considered the variables of sex and gender in your own work, going upstream to not just journals, but to publishing houses. Because if you look at some of these huge medical publishing houses, there's lots and lots of journals under their umbrella. And if you can change the template for that publishing house, if you can change what you are expected authors to submit, you can rapidly change the culture of medicine. So the SAGER guidelines essentially go very quickly through all the different parts of a paper, and they want first to make sure we're using terms correctly. What's biological sex? What is gender? There should be no use of the word gender in biological sex basic science research. If study subjects have identified biological sex, have the researchers designed and conducted it in a way to capture these differences. So when we look at a title, we should be able to see if that research included both sex or just one sex. There's been many, 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 many papers published in the last 3 decades where it looks like you are looking at both biological males and females, but when you get into the paper, women, males were never included. When we look at the introduction in these papers, there should be a sentence or two to say, what do we know about sex and gender differences if we do know anything about the science in the area that's being studied? In the methods section, have the researchers looked at any sort of calculation in their design to make sure that they have included a number that would give you at least some information if there is an outcome difference, that there might be some validity in that difference. And if they are including just one biological sex, and clearly there are some studies that are justified and we need to do that, have they given us a good reason as to why? And the results, this is our low-lying fruit that we are really, really sort of on the charge to make sure that we encourage everybody to do. Don't just include your demographics in your figure 1, but tell us what happened to men, what happened to women, what happened to non-binary. However you collected, just give us the outcome data analyzed by biological sex. And in the discussion, have you included the implications of these differences, whether they are positive or negative, so that other people can learn from them and potentially develop more studies in the future to further discern these differences. Now I'm going to hand it over to one of my very capable colleagues.
Thank you. I'm James Paxton, Wayne State University. One of the reasons I was asked to participate in this session is that I have served as a chairman of the Institutional Review Board at my institution, and I can speak from some of my own experience as an IRB chair in discussing some of these concepts. I think one of the things that you recognize right away working with an IRB is that these are just regular people. Some of them are physicians, some of them are other clinicians, some of them are laypersons. We've had on my IRB lawyers, clergy, housewives, just lots of different people, diversity of opinion. But I will say that, in many IRBs, people tend to be a bit older. So I think in my IRB, the average age is probably 55. So I was on the younger side in my IRB. And so I think sometimes some of these concepts are a bit generational. And I think that sometimes you need to educate individuals on the IRB about some of the things that they may not have come up with in their time previously. So one thing to point out is that the IRB is really has been formally designated by federal law to review protocols, and their primary function is to protect human subjects. So they are most interested in that room in how does what you're proposing as a research protocol affect subjects, affect human beings who are enrolled in your study, and they're looking at risk-benefit ratio primarily. But I think that a key thing to remember here is the IRB is also a regulator of what research happens, and in many ways not that different from what was just described regarding publications and journals. If you want to affect change in the way that things are handled, such as sex and gender, yeah, definitely, having those discussions at the high level of publication is important, but at this level it can be effective as well. And I think having an IRB that is familiar with these concepts will also help to promote the proper use and a proper study of these kind of topics. So. One thing I would like to point out about IRBs is that traditionally, institutional review boards were local entities. And I think that was really how it was intended when the guidelines were established. And we're talking about things that happened literally before I was born. So, for example, the National Research Act of 1973, which was finalized in 1974, written into law by President Nixon, the Belmont Report, which was even older than that. So these are things that happened in the 50s, the 60s, the 70s to research, and this was how research was designed in this country, how the infrastructure was created. The reality is it's 50 years later, and things have changed in our society and globally. And so rather than allowing local IRBs to regulate research, what the federal government has decided is that they are going to start trying to effectively force researchers to have a central IRB, which is to say that rather than having my local Detroit IRB approve a study that's multi-center, they want to have it approved by a third party for all sites with reliance from the local IRBs. And there are challenges in that. There's advantages and disadvantages to that. But I think one of the advantages of that is if you want to introduce education and reform and change, it's a lot easier to do when you have these third parties that are seeing lots of different protocols. It's much easier to educate when there's fewer people who need the education. So I think that's a potential advantage under the current structure and what's coming in the future. One of the things that has already been mentioned is that research and, in fact, protocols in the IRB have previously considered sex and gender very differently than perhaps what we do now. And I don't want to belabor the point, but I think it's worth mentioning that IRBs may function on a level that's 10 or 20 years behind the rest of us. Not just because they're older in some cases, but also because they often operate on tradition. This is how we've always done it, right? It's like any other volunteer organization. They have an unwritten protocol. This is how we usually do things. I can tell you that from my personal experience, very few times that we had discussions in that room about sex and gender. Very few times. And the few times were usually cases where that was the topic or the focus of the study, right? And so I think realistically that many of the studies that have been approved by IRBs and probably will be approved in the future probably don't have a good handle on this concept. And some of the points that are brought up with the SAGER guidelines and some of the points have already been discussed are probably going right over their heads, honestly. So I think one of the roles that we are going to have to promote and serve in is an education role for IRBs, not just for our study teams, but for the people who are making the rules and regulating research. One controversial comment might be that if the data is not central to the research question, maybe it shouldn't be collected. And I think there are multiple perspectives to this, but one of the things that you recognize when you look at how research has been conducted traditionally is subjects were not generally asked. Do you identify as male, female? And I think that is an important point, right? Because a lot of this data are collected by a third person from the electronic medical record. And I can tell you as a clinician, I've seen several cases of instances where people were not correctly identified in the electronic medical record. So if we're making decisions about clinical management and demographics about population health, maybe we shouldn't be using the wrong data. So I'm not discouraging, and I wouldn't discourage studies that relate to sex and gender, but I think it should be done correctly. And IRBs should probably be enforcing that individuals who are doing studies that collect these data are collecting them appropriately with some safeguards to prevent incorrect data being collected. Switching gears just a bit, talking about IRB, I think it's important to mention vulnerable populations. This is a concept that's brought up repeatedly in the Common Rule, which is also 45 years old almost. And one of the things that's very clear when you read the regulations, the federal guidelines, is that certain populations are called vulnerable populations. And so why would we say that certain populations are vulnerable? Well, the groups that are considered vulnerable include prisoners, people with mental illness, children, pregnant females, and so on. And at the end of the day, the reason that they classify them as vulnerable is they want to make sure they have extra protections. That's the term and phrase that's used, extra protections. One of the disadvantages of extra protections is it raises a bar and makes it harder for those individuals to be enrolled in research. Especially EFIC type research, but also other kinds of research as well. And it needs to be justified in the protocol why you're enrolling these individuals. And if you can't justify it by the disease that you're studying or some requirement of the study, then they often will not be allowed to include people from these populations. And you can understand in regards to consent that that may be an issue for people who have mental illness, may not be able to provide their own consent. Prisoners may be coerced by their circumstances into participating in research. Those are obvious. Children for the same reason. Sometimes parents will just say, nope, you're doing it, don't care what you think. And so I think it is appropriate to have those safeguards. But sometimes the idea of pregnant women, for example, being excluded from research doesn't necessarily make as much sense with the modern sensibility. One of the problems we have with treating pregnant women is not a lot of interventions have been studied appropriately in that population. And so I think rather than simply excluding them or putting them in some elevated status, maybe it's more appropriate to explain differently what the risks are to their fetus, to themselves, perhaps, if their physiology is different in that way. But rather than excluding them or promoting their exclusion, just give them more information that's relevant to their circumstances. And so I think that would improve the health care that we can provide for pregnant women as well. But it kind of ties back to an idea that the federal government had of being protectionist, kind of a parental figure, if you will. And that's not going to change, but I think one of the things we can do is we can educate our IRB parents as to how they can and should be managing and regulating research. And just remember that when you're working with the IRB, they're a diverse group. They come from all different backgrounds. Some of them may share your vision and view of sex and gender. Others may not even have heard of these concepts. And so we don't want to ask them to assess and regulate and control research that they don't understand. And so it's important when you're writing your protocol to explain, these are the things that I'm addressing, this is why it's important. And then I think it's worthwhile considering extra arguments to be made for the inclusion of vulnerable populations, especially, I think, pregnant women in some studies. So I think it's a kind of collaborative effort between the IRB and the investigators and other regulatory folks to try to advance and improve on our management and our understanding of these concepts. And it's really going to be a dialogue going forward. It's not just going to come from us or from the IRB. It's going to be an exchange of ideas. So I think that's a point that should be made. And thanks for your time. That's my last slide.
Hi, I'm Basmah Safdar, faculty at Yale. I appreciate the fantastic presentations by Dr. Wolfe and Dr. Paxton for really setting the stage of why are we doing this, what are the definitions, and how do we incorporate on a systems level. So I'm going to continue that conversation and build on that to essentially hope to demystify the process of how sex as a biological variable is being incorporated in NIH guidelines or NIH grants. What are the requirements and where that comes from? I think to put that in context, it's probably helpful to also take a step back and see why NIH is suddenly interested. So in 1993, till 1993, women were really considered like a vulnerable group and were excluded from most of the research because they had to be protected. So it was not till 1993 that the Congress passed an act and NIH made a change. And since then, NIH made a concerted effort to include men and women in clinical trials. And the 2021 data seems to show that they actually did pretty well. Most of the NIH-funded clinical trials have about half and half of distribution. Having said that, they look at it, on a periodic basis, and so in 2014 they realized that that change hadn't yet been made to preclinical research, and so in 2014 they figured out that 80% of the basic science research or animal models were male models, and or they were not the sex of the animal models or the cellular or the human cells that were being used was not disclosed. And so that information was just being lost. And so NIH again took an initiative and in 2015 created this new initiative of sex as a biological variable that now needs to be incorporated in all kinds of research. So we'll go through, my job in the next few slides is simply building on the definitions that we've actually used and just point you in the right direction so that when you're using your grant or putting in your research, you know where to look to actually incorporate the sex and gender research. So now in 2016, NIH expects all grants to factor sex. And if you're using one single sex, to have a really good justification, both in the background, in the analytical methods, having a really good justification for that. And so examples of the trans NIH efforts is essentially their principle is that just like you do randomization and consent and blinding and all other principles, incorporating the influence of sex on your study outcomes is just as important as an experimental design. And so that's the premise of that. Until you do that, you will not change care, down the stream. So their emphasis is to actually make sure that the animal models are as close to the human models, that sex is being incorporated, so that the sex-specific diagnostic data is gathered, as well as on therapeutics and outcomes. And so the Office of Women's Health Research has actually done a lot of work in really trying to simplify that process. So other than the definitions that I haven't gone over because Dr. Wolfe had already gone through, but really clearly define what sex is and what gender is, they actually have these e-learning modules for anyone who's new to this game and is trying to learn how do I even use the language in my grant. That's the place to go. These are all free, and they have for basic sciences researchers, so how to use the bench to bedside, how to integrate sex and gender to improve human health. Probably the most valuable one here is the sex as a biological variable. It's a primer, and it actually goes through all the definitions, but also the analytical methods and gives examples of that. So it's a really worthwhile going through it when you're just sitting down to write your research, because now it's a requirement to put that in. They also have, for anyone who's trying to do that on an institutional level, like IRB, they have Train the Trainer. So it has all the language and the slides for what you need to actually just educate people. And these are like not long, 20-minute ones for you to actually go through and see how to incorporate that information. And then they have the core concepts of how it actually applies to all different health and conditions. So those are the 4 E modules that I think I thought you should know about. I talked about the SABV primer, which I thought was probably the most useful one. It gives the background, gives examples, but also describes how you actually incorporate sex as a biological variable in your experimental design, what are the different analytical considerations, and then finally the research reporting. And then this was, I referred to the Train the Trainer, where it actually talks about, they have appendices, and they have, the reading materials and everything, and tons of materials that you actually don't have to recreate if you're actually trying to disseminate this information at your institution. So I look at, incorporating this as two-stage process. You may not be a researcher who's focused on sex differences, and that's okay, as long as you incorporate it in some way. So your first thing is to just look at that data and incorporate sex into your design and analyses at minimum at a disaggregated level. And, I write papers, right, like my focus on sex and gender research, and yet, sometimes the results are not significant, right? But I think it's important to still present the information. It may not make into my 5 tables and figures requirement for most papers. I just put it as an appendix and refer to it. Because that's, my idea is that information should be out there, whether it's significant or not. Either ways is actually really important, so that somebody else is not wasting their time. Or understand that what are the limitations of that information. And so, in your research strategy, how you include in your analyses, at minimum as risk stratified, but then if you're trying to do more, then you need fancier analyses and power calculation. But having really strong justification in the preliminary data is a basic requirement now. It's in all of the NIH grants, the FOAs. This is a language that comes directly from that. So just be familiar with that, because you have to now justify it. But you should also know how the reviewers review this information. So I thought this was helpful because the Office of Women's Health Research put it up, and I actually didn't know that. But it's really helpful to know how they look at it. So the first step they do is looking at whether the study involves vertebrate animals or humans. And if it is yes, then their next question is if the study is intended to test for sex differences. If so, then they want to make sure that you have done the power calculation, you have the analytical method that Dr. Madsen is going to go into more detail. And in general, when you're doing sex-specific interactions and hypotheses testing, you actually tend to require larger sample sizes. That's all I remember. She's going to go in much more detail. But justifying with your full analytical methods. But then at minimum, if it's not focused on it, then you just need to at least present your data in a disaggregated by sex, and then also provide, if single sex, then really provide the background and the research, because it may be disease specific, right, or like ovarian cancer or testicular cancer, but it may not be that disease specific or sex specific. And as long as there's a good justification for why you're doing it, you're good. The next level is to actually use opportunities that are now being put forth. So there's actually an RFA that invites you to put sex-specific research grant on an R01 level. This is one of the trans collaboration of the Office of Women's Health Research with multiple NIH institutions, and I think which includes almost all of them now. They didn't have NHLBI for many years, but a year or so ago, they also incorporated NHLBI. So whatever research you're doing, if you have the information and can do a dig deeper, there is an RFA announcement that you could actually take advantage of. And what it requires you is to be responsive to one of the three things, the definition of sex, definition of gender, and these are the definitions right off there. I think some of it was covered. And then one of the 5 objectives is the strategic goals that have been put forth by this Office of Women's Health Research, which actually covers a lot of work that we do, because what we do applies across the spectrum that it invariably fits in. So I like to give examples of where we've actually applied some of these principles, and I will give you a failed example, and then Dr. Madsen will also give you a successful example, just to kind of give you an idea of what works and what doesn't work. So this was one of my grants that I was looking at that time, effects of exercise, particularly cardiac rehab in patients who undergone surgery, and I was interested in looking at sex differences in the fitness levels with all these, biological differences and the cardiometabolic panel, body composition, autonomic reactivity, and then also looking at the gender differences and referral pattern, as well as the completion of their cardiac rehab. So this was to this RFA. It got scored, but didn't get funded. I just wanted to just kind of see how the viewers are looking at it. And so what I saw, there were strengths of the teen and blah, 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 but there were also, what was lacking was how the conceptual model of putting the sex differences in, and then what they truly commented on was also looking at sex hormones. So when you're putting something that specific, which is so geared towards a sex-specific RFA, you may need to take that to the next level, which is also looking at not just the biological differences by DNA and chromosome, but also looking at the hormonal differences. And so, the main critique was having that thematic mechanistic framework, steroid hormones, and then also the final comment was for age-matched male controls, we should be including postmenopausal women. So I just wanted to highlight some of the things that actually came about, because I think they may be relevant to other people who are doing this kind of research. With that, I'm going to pass it off to Dr. Madsen so that she can continue the conversation on what worked for her, and also take us to some of the analytical methods that I mentioned. Thank you. You do it.
All right. Thank you all for coming on Friday morning when many of the other attendees are on planes already. So I'll tell you a little bit about my grant and kind of what perspective I took when I was writing it kind of through this sex and gender lens. And I will point out that this was not the same RFA that Dr. Safdar mentioned. And so I'll also mention that this was not a first pass success. This was the 4th K-23 that I submitted on similar topics, so there was a lot of learning involved. So what I kind of needed to do for the reviewers to make this successful was that I needed them to understand why it was important to look at this through a sex and gender lens. I think the first couple iterations of the K-23s that I wrote, that was a major critique, that they didn't understand, basically like the significance wasn't high enough. Why are you looking at this by sex? Why is this important? You have to really understand, I think, that the reviewers in general are not going to be sex and gender experts, and this is new to many grant reviewers, so you have to really convince them that this is an important thing to look at. And so it took me, like I said, I think 4 iterations to come up with a significant section that actually convinced the reviewers that this needed to happen by biologic sex. So this was a grant on stroke. I worked very hard. Like I said, this is just an example of the significance or background section describing why we needed to look at stroke risk by sex. And so this is just from the specific aims page, but I had many paragraphs explaining this in the significance section. And then I went into the kind of the scientific hypotheses, again, that Dr. Safdar started to kind of talk about. You really have to make the reviewers understand what is the hypothesis, what is the mechanism proposed between, for example, in my grant, sex differences or sex hormones and stroke risks. So not just kind of saying this is what we're going to investigate, but proposing a biologic mechanism that can be achieved in the grant. And so we looked at things like inflammation, lipid metabolism, insulin resistance, and this grant is still ongoing. I'm in my last year. Let's see. And then I'll just give you an example of the aims and kind of how I looked at sex differences in stroke risk through the sex and gender lens, or stroke risk through the sex and gender lens, I should say. The first aim had both male and female participants. This is largely a grant looking at secondary data analysis, so data that already existed. And so I was able to find multiple existing cohorts that had both male and female participants to look at truly sex differences in risk between certain risk factors. So things like hypertension, diabetes, and there was good preliminary data to support me doing that. The second two aims I was a little bit more nervous about because of they're included only female participants. And again, as you've heard already, it can be more difficult to get a grant funded if you're only including one sex. I had to really make the reviewers understand that the scientific hypotheses that I'm trying to test were specific to females, and this is why I was using the Women's Health Initiative study, which is only females, and I was asking questions about sex hormones like estradiol, asking questions like reproductive health history, age at menopause, parity, things like that that really can only be measured in biologic females. And so I think that's one of the reasons that they were okay with me looking only at female participants for AIM 2 and 3. I did, however, kind of explain pretty extensively how in the future I would use the skills that I was gaining and then the data that I had collected to apply some of these principles and do future work that included males as well, to make sure that I was kind of covering all my bases. So this is mostly for Dr. Safdar's section, but for NIH grants, she talked about explaining strong justification for single-sex studies, clearly understanding the definitions of sex as a biologic variable, incorporating SABV in your study design, rationale, analytic plan, and power analysis. And I'll talk a little bit more in detail about that in the following slides. And then for sex-specific studies, looking at mechanism. Okay, so I have a lot to cover. It's a fairly broad overview, but hopefully we'll have time for questions at the end for the rest of the panel members as well. You really have to think about sex and gender variables from the very beginning. So when you're writing your grant, or if this is unfunded work, when you're designing your study, I think we often see kind of people, like I'll have junior faculty or trainees come to me with a data set and be like, what do I do with sex and gender in this data set? And not to say that we can't help with that, but it's really important to look at it from time zero when you're first designing this study, so you collect the data in an accurate and methodical way and you understand sample size and all of that. So we'll talk about that. We'll talk a little bit about literature review. I'll just show you quickly a tool if you're not sure about what the sex and gender literature are in your particular field, which helps with your hypothesis generation. We'll talk about study design and analysis, kind of comparing some of the challenges with prospective studies to retrospective studies or secondary data analyses. We'll talk about recruitment strategies and some statistical thoughts about power calculations and analyses that you could consider. So this is just kind of a resource for you that you can take with you or share with your trainees and faculty. If you're not sure what exists in terms of sex and gender differences in a particular area of work, this is it's a PubMed, it's a validated PubMed search tool. So essentially has created an entire paragraph of search terms. All you have to do is put and add your topic of interest. This is the way that you get to it. It's I think the website is up there, but I can give anyone the information if you want it. It's available online. You basically click it, you can cut and paste it into your PubMed, and this is a great way to find papers that already exist as you're designing your study. So moving into the second category here, thinking about study design when you're looking at your study, if you're doing prospective work, which can be more challenging, how do you recruit enough females, enough women into your study? I often see, when I'm on grant sections, or looking at proposals, I see proposals that do a really good job of describing how many women they're going to enroll. So when I'm in, for example, stroke grants or stroke proposals, I think researchers are very aware that we need at least 50% women enrolled, but there sometimes is a lack of understanding in terms of how do you do that. Because once you start enrolling, if you don't have specific techniques and strategies to get 50% women into your study, you're going to have a hard time. And of course, it depends on the study population and the condition that you're studying. Trauma, for example, where the preponderance of patients may be males rather than females. But you really have to plan this up front if your study is prospective. So thinking about your eligibility criteria, how patient attitudes and beliefs might affect their willingness to participate, whether or not you have community-based outreach, and then implicit biases and how you can get around biases of your study team and how you can more effectively enroll women. A lot of these principles also apply to enrolling underrepresented groups into research, and it really is very specific to each study. So you have to go through your study population, figure out what challenges you're going to have, and how do you meet your enrollment goals. Because if the end of the study comes and you don't have 50% females, or you powered your study based on 500 women, whatever it is, and you didn't make it there, then you're going to have a problem with analysis. So things like for stroke, a lot of these apply to stroke because that's where my brain lives most of the time. But something like eligibility criteria, considering avoiding age-based exclusion criteria. An example is some of the big thrombectomy trials that came out a few years ago. Many of them had an age cutoff, and so then you look, and it's much harder to enroll women if you make the age cutoff 80 because a lot of the women having strokes are older than 80 years old. Thinking about gender-specific attitudes and beliefs. So in some settings, women may be less willing to participate in research, maybe feel more risk-averse and kind of more worried about the potential adverse effects. So considering that, considering community-based recruitment, and then the biases among researchers, having a diverse study team, a diverse group of people that's going to enroll your patients and approach your patients and try to get them to participate in your study is really, really important. Patients need to see someone that looks like them, that understands their concerns, et cetera. I'll give you kind of one quick example of recruitment and retention that I learned or I'm learning from my current grant. I have a follow-up blood draw for my postmenopausal women that I'm enrolling with stroke. I'm working with a pretty limited budget because it's a career development award, and I quickly realized that that 3-month follow-up blood draw is very difficult. It's very difficult to get older women back to the hospital, even if you're giving them compensation to come back. So we tried things like Uber Health, taxi cabs, and that wasn't really even working that well. They just either couldn't or didn't feel like they wanted to come back to the hospital. And so we had to kind of go back to square one and change the protocol and do home visits for the 3-month visit to meet them kind of where they were in the community. So moving a little bit more into the analysis section, power calculations. And this varies widely based on what study question you're asking. What is your study design? Is it retrospective? Is it prospective? So it's important to sit down with your statistician and really hone in on your research question and how does sex and gender work in that research question. Is it the primary exposure variable? Is it a covariate or a confounder? Are you going to stratify? Because this is going to directly inform how you do the power calculation. And so it's important to understand that in your mind, kind of what role does sex or gender play. So some of the examples, you may be powering your study to detect a sex difference, for example, a sex difference in a particular outcome. And then your power calculation probably looks pretty similar to other power calculations that you've done before because you're comparing two groups. That can be more straightforward. It's less straightforward if you're trying to power a study to detect sex-specific effects. So whether or not you may be stratifying your sample between males and females, and then if you're going to detect a difference in the treatment outcome for women and a difference in the treatment outcome for men, you're at least doubling your sample size. So you have to think about budget then. Interaction terms can also be tricky, but is another good way to look at sex differences. This makes your sample size much larger, and I would certainly recommend working with a statistician for which your interaction term, what are the types of variables going into the interaction term, continuous, binary, et cetera. And then you have to do a specific power calculation to power your study to detect a significant interaction term, which can be challenging. There are some kind of schools of thought that you can relax the type 1 error with interaction terms. So we typically say p less than p.05 is significant, but there's some thought that you can relax that to like a p equals 0.1 if you really want to be sure to detect a difference between sexes. So that's something to consider. What is your type 1 error, for example, which might help with study size. This is really a challenge when you're trying to write grants or detect significant differences between males and females when you have to enroll double or quadruple the sample size. And then thinking about sex and gender as a secondary exposure variable and how that might work in the power calculation. Data collection, I won't spend too much time on this because I think the other speakers have mentioned it already. If you're prospectively collecting data, making sure that your case report forms can accurately collect that data. And then if you're doing retrospective studies or secondary data analyses, trying to explore in the data set what data are already available to you and are they adequate to answer your sex and gender questions. This is just an example of a two-step question that you could use on a survey. This is from several years ago at this point, so there are already limitations with this. But you see a two-step question, female, male, intersex to look at biologic sex, and then transgender. But I think more updated kind of recommendations for gender questions and surveys have even more response options than this. Data analysis and reporting. We've spoken a little bit about analysis already, but it's important to report, and Dr. Wolfe spoke about reporting, but you're going to report sex and gender in Table 1, and then you're going to put sex and gender specific findings in your other tables, either in the primary paper or in the like the supplement, if it doesn't end up being your primary question. We're almost out of time, so I'm just trying to see. We talked about single-sex studies. I'll just do one. I think this will be the last slide, and then we'll stop since we're almost out of time. But analysis strategies, again, you're going to be sitting down with your statistician and talking to your statistician about what your research question is and how sex and gender should be incorporated. And it's important to really have a strong sense of that yourself before sitting down with a statistician because they may not understand what you want to measure. So thinking about is sex, and so sex or gender, is it your exposure variable? So that means it has to be in your models. You're going to force it into your models even if it's not statistically significant. Is it a covariate? Are you going to consider matching or other potential causal inference methods to reduce bias in your models? Interaction terms is a great way to start kind of exploring whether or not there's a sex and gender difference, and then you can decide whether or not to present primary data that are sex disaggregated. This, I think, is a pretty common method that you see in the clinical literature, is putting in an interaction term, and then if you get a signal, then separating the data between male and female and looking at the effect estimates that way. And again, this is going to be very specific to your study question, so I recommend sitting down with your team to figure out the best analysis strategy. There are lots of statistical hypothesis tests that you can use to I guess, draw conclusions or say that there's statistical significance. For example, logistic regression, you might use a Wald test with your sex term or your interaction term. I've seen papers that kind of build separate models, some with the sex interaction term, some without it, and then look at either nested models or compare model parameters. And then there are ways to test for heterogeneity between effect estimates if you're stratifying your sample. So this could be certainly its own talk, thinking about analysis strategies, but really important to think about carefully. And I think we've covered everything else.
We'll take any questions. I mean, this was like a full exposure to a lot of topics. We just wanted to introduce new topics.
I wanted to ask a question about the IRB composition in the room. You mentioned the age composition. I wanted to know if you could comment on the gender composition in that room.
It's a great question. interestingly, I think, first of all, we never really discussed, we could guess or assume, but
Right.
we never really had a discussion as a group about gender.
Right.
But I think, I would say it was about half women, half men, by sex, but it's hard to know. I mean, and that might actually be one of the things that needs to come up and be discussed in the room, is, what are our assumptions about sex and gender in this room, on this committee? And maybe even some exercises, to try to raise awareness about assumptions versus facts. And I think that's relevant to the data collection. We talked several times about data collection, and is it accurate or not? So, but yeah, I would say I didn't identify a problem of underrepresentation of females by my estimate.
How much influence do you think IRB has on, the data they collected?
Research, whether it's done well in this way?
Yeah.
Probably not right now,
Yeah.
because it's not on their radar. They're not looking for it. It may never come up.
But they may come back and ask for it if it comes to that point.
I mean, if it's, certainly if it's like a primary focus of the study, the IRB will often, call someone in to talk about the subject and give them more information, but, most studies aren't specifically targeting sex and gender differences, so I think in that setting, it may never even come up in discussion, and they may be looking at other things and not even notice if there were flaws or problems with the study because they're just not aware, perhaps, of this issue.
I think we just came up with our didactic for next year is what is the toolkit to get to our IRBs for sex and gender
Yeah,
differences.
I think that's a toolkit. That's how we started 10 years ago, with like every topic we've been actually covering. And this part of
How
it
do we
is
target people who need to be in the room who are not here?
papers.
Can
Podcast.
I ask you a question? So in your experience on grant study sections, how closely do people look at sex as a biologic variable? And do you find that you're often the one in the room kind of pointing it out or saying there's a problem or?
Yeah, often, yeah. It's because it's the same thing. Most people are, average age is older. So even though they're and there's some people who are very resistant, right? Like because especially basic scientists, like who had completely changed how they had to do things, there was a lot of resistant questions about it. And so it takes about 10 years to change, culture change. So we're right around that time.
As an aside, Herb Zucker, who is the person who really pushed the biological sex of the data with his basic science researcher, he talks about doing back-to-back grant routes at Michigan and Michigan State, introducing this before the government picked it up. And he said he's in this room full of just basic science researchers, and they're like, were people super enthusiastic this was coming? He's like, absolutely not.
No.
They're like, we do not want to do this. This is just
Yeah.
going to be a hassle. So we think there's a cultural change in clinical medicine. The basic scientists are behind us.
Yeah.
I was going to ask a similar question. Thank you for presenting. Like, what feedback are you getting, like, on the K? Like, was there any interesting feedback? And is there any tracking of funding specifically for these differences? We do it in pediatrics because, pediatrics is not little funded in NIH overall, so we try to keep track so we can advocate for more funding. But I was wondering, I have to run to moderate the tail end session at 12, so I apologize. But I was wondering along the same lines of that, like feedback in the study section.
Yeah, I think it depends. More if the epi ones are a little more receptive than the basic science ones. So I think yours will probably be, pediatric will probably be the more epi-based study sections.
I think that's true. I don't know. I don't think that the standard study section is giving a lot of feedback on this.
Yeah.
It's on the list of things we're supposed to look at, but I think
There's probably movement on
room to
endocrine
grow. Yeah.
right now because that's a big, and endocrine study sections and is that NIDDK? NIDDK might, you may see more movement there. You may want, I'm not in that space, so you may want to speak with them.
I think with immunology and COVID, there was such
Oh, yeah.
a huge emphasis on some cytokine differences between males and females, again, an area we just never thought of how hormones intersect with that. So it's coming. It's just coming little by little. We want it to come like this and up.
Yeah, and I'm also curious, I haven't spoken about the National Institute of Mental Health, and like I worry specifically about adolescents who are LGBTQ+, like there's some preliminary data that they are struggling worse than everyone else. But anyways, thank you guys for the presentation. I'm so sorry.
Yeah.
Thank you coming.